Okay, so we have, thank you, Philipp Hafen, who's from Hochschule Frank Wagner University. Is that close? Furtwangen. Sorry, University.
It's not the easiest name.
And they're going to, this is from, so again, the university are going to talk about robust auto detection of camera lens distortion parameters. So with that, Philipp.
So what we want to do is correct the distortion from an image. You can see here in this case where there's the bended curve, or which should be a straight edge, and here it's undistorted. And to achieve this correction, we use checkerboard patterns to calculate the necessary parameters, which you can see here. It's the distortion center, which is the center from which the distortion, which is radial symmetric, which is from where it originates, and the polynomial to fit to correct this distortion. And our quality measuring unit, which I can explain a little bit later. Our first step is to detect all the x-corner points. It's a bit hard to see, but all the points between the squares. Therefore, we blur the image so we can build a it's 3D in this case, but it's not really 3D when we calculate it, but we can in these planes, which come from these blurred images, we can calculate the saddle points between the high planes and the low planes.
So it's like the best compromise.
Yes, that's the compromised version. Then we have all the points to accommodate with bad lighting. We have an adaptive threshold where we cut the picture in smaller pictures, where we couple the variance of the lighting of the illumination, so we can find all the points even when they're not. So, in this case would normally not happen with this bad lighting, of course, but you don't always have the ideal equally distributed lighting like in this case. Then when we have all the points found, we want to find the place where there would be if there wasn't any distortion at all. So to do that, we first need to know the distance between 2 points when they're not distorted.
Describe what a pincushion distortion is, just so folks know. Mainly there are two kinds of distortion: a pincushion distortion and a barrel distortion. Okay.
A pincushion distortion, you can see, it's just like a pincushion. It bends this way.
Yeah.
Yes. Oh right.
The one you're showing is barrel.
Yeah. Yes, it's barrel. Oh, sorry. Yeah.
Sorry.
Like a barrel. Yeah. I get confused. Yeah. A pincushion,
This is the advisor. Yeah, that's right.
Yeah. I confused these two.
Okay, that's all right.
Well, the pincushion it goes that way, and the barrel that way.
Okay.
In short, yes. So when we
So that's what you're doing here, is you're kind of optimizing between those two different distortions?
No, that had nothing to do with the distortions at all.
Just with the
No, that's, if you look at these 4 squares are just some squares you find here.
Okay.
This is to find the x-corner between the 4.
To find the intersections.
Right.
Ah, okay.
Because we need the intersections to describe or to compare the positions of them in the distorted way and the way they would be if there wouldn't be any distortion.
So you deal with the pincushion distortion?
The same way we deal with the barrel distortion.
And the barrel distortion is the one up here. That's where it's like distorted like that.
Yeah, but we handle it the same way. It doesn't matter which distortion.
What's the limitation on the distortion that you can correct for? Are there practical limitations on what you can do?
Our case, we need to have a orthonormal view of on the target.
So you don't want any parallax.
Right, because if you don't view it orthogonal, you don't have a radial symmetric distortion.
Okay.
You get a skew, and we can't. Our approach isn't designed to handle these
Gotcha.
these cases. Right.
Good.
Okay. Where was I? Right. We have the locations of all our intersections in the distorted case, and to find the location of these intersections in the non-distorted case, we need to identify the distance between two intersection points in the non-distorted case. Our model follows that in the center of the image there is the least amount of distortion. So in the center we assume there is no distortion.
That's like your reference.
Right. So if we search in the center area and calculate the distance between 2 points, and with this distance we can compute a grid with the locations we think are in the perfect fit where they should be. And combined with the place where we assume the distortion has its origin, because our polynomial we use to correct this has its origin.
And that's from the reference point.
Right.
That's the origin.
Right. That's the origin. And if we have both the locations of our points distorted and undistorted, we can calculate this polynomial to fit or to correct this image.
Okay. Okay.
And that's basically it. Yes.
All right. Well, thank you very much. Thanks.